Hello. In this video we are going to recap a little bit the current state of this Tripscode program that I am developing here. And what I wish to say, this is for myself and for anybody else that wonders what is going on in this program. This is a freeware project, and now it has several features and abilities that are, in my opinion, also significant, because it has those patches feature that in the future it is meant to be like a modeler also, but currently it has animation features, character animation, and several features that animation requires. But then I started to think what should be the next thing that maybe I do in this program. And one thing that I considered was rendering improvements. And to talk about renderer, it has Swift multiprocessor rendering, but no graphics card based renderer when it is initiated inside. When it's about viewport, this is OpenGL, but the fun part should be to self-produce some rendering abilities, and for instance some realistic features that today's renderers have. But I have nothing of it. I have only a single light source, and a picture comes out of it. It has materials, textures, transparency, and some basic features only. And this produces no shadow effect also. But to start with the renderer improvements, then we first need to consider camera improvements and light improvements. And the idea is to create a dialog that you can choose the start and end frames and give the file name, and then produce the renderer out of the animation. But the animation part of the program needs to be improved first, and this involves, for instance, the camera movement that we wish to have. Also, we need to add more lights to the scene, the light environment, and the themes connected to the lighting need to be implemented. And currently this reflects in this item list that we have objects though, but no cameras, no lights. And if we ask where the cameras are, then those are the in hierarchies list we see 5 cameras, and they are built-in views for front, side and top, and perspective views. And camera 5 is the material renderer that renders the thumbnails for materials. Those are the spherical representations of the material. And this is the 5th camera. Those cameras need to be intact. We shouldn't be animating them directly. And that's why the improved system, or the future prospects for this system, are abilities to add new cameras, new lights, and operate also on animation with them. And what's the animation part and how it looks like right now is this keyframe timeline is ready, and also the ability to add keyframes and accelerate and decelerate inside those animation segments that find themselves between the keyframes. And here we see also the animation segment here, and if I press up and down, then I choose the segment's type. And if it has this highlight in the middle of it, then it accelerates in between the keyframes and decelerates on the keyframes. And such features are ready, but this acceleration, deceleration, they still don't produce the required requirements of the animation, because in real life, if we pick an example of the flying, then we see that it has curved trajectories to it, and those curved trajectories they need to be implemented in this program. Currently those trajectories for a transformer that goes through those keyframes are linear, and that's the one thing to do. And currently I have restricted also the ability to put keyframes. Keyframes can be only applied to the former objects, and that's why this transformer that we observe here belongs to this deformer here. This drawing here means that this is the former, and the transformer is parented to this the former object, and this is set up here. And the idea with this is that I can displace the former, and this animation should happen in a new place where I move this deformer. The animation itself remains the same, but it happens in a new location. I don't even know if I could rotate this whole thing, for instance, to a new angle. And if I play, no, rotation is currently not possible, but only location displacement. Alright, those are many features that need to be implemented, and the program needs to be improved by these features. And that's maybe the next steps. And to achieve these trajectories that I was talking about, this is the one task before we go to the next bigger steps in the system. And those trajectories should then be a new object inside, maybe in timeline structure or something. Let's take a look here. We have a timeline here, and if I can spot this structure, here we see timeline structure is one thing, and the morphed timeline is another thing. Why this timeline is two levels: the morph keyframes are above, and the regular animation keyframes are below. And the below strip, if we talk about this timeline shape, if we observe it here, this has two levels: morph keyframes and timeline keyframes. And timeline has transformer values. We highlight here. We see this involves position and the rotation and scaling of the transformer, and those transformers really drive all the effects in this program when it is about an animation. And here we have also acceleration array. This corresponds to this segments. Every segment has this acceleration involved. And then how we should proceed with this adding this trajectories feature, because it currently takes only linear interpolations when it is about positioning. When it is about rotation, then this is not an issue, because rotation doesn't involve these trajectories. And then we should maybe improve this timeline structure and create a trajectory element here. And those trajectories in itself are then really pre-calculated positions for every frame, and they are calculated from the keyframes or frames. Keyframes is the amount of frames, but the frames are here to represent those let's see. Anyway, I need to be a little bit exploring it before I talk about it, but we see here in general this acceleration array and values array, they have the same length of amount of keyframes probably. But what is this frames value? Maybe search. Frames are integer values, and keyframes are the amount of the frames. That's what I see of it. And then those trajectories need to be applied in addition here, and we need to update the file format for this new saved type. And when the file format has trajectories, then the loading routine is more up to date. And if the file format is obsolete, so to say, then the loading procedure skip this new trajectory feature. This is loading and saving are also different topics here. And then those trajectory arrays really should look like they are not for per keyframe, but they are pre-calculated positions for every frame in the timeline. And the timeline equals first frame to the last frame in the animation. It is not infinite. It is the only this amount how much you have animated something. And it is not also feasible to create for every transformer this amount of frames, but only for those animations that we switch on this curved trajectory feature. Then those calculations should take place. It's maybe to compact the memory.